Welcome to Kaiju Mathematics. Today I will be tackling estimating a population proportion. So I have this problem here. In a survey at a local college, 1,100 students and staff were surveyed if they listened to podcasts while driving. Of the 1,100 people surveyed, 652 indicated that they did listen to podcasts while driving. Construct a 90% confidence interval for the population proportion of college students and staff that listen to podcasts while driving. So there's a number of different types of estimations that we can make about a population: proportion, mean, standard deviation. So in this scenario, I want to do proportion. First, when we're looking at estimating a population proportion, we want to get our p-hat value. P-hat is going to be the sample data. The sample data here is that of the 1,100 people, 652 out of 1,100 indicated that they did listen to podcasts while driving. So I'm going to take that as my p-hat value. So 652 out of 1,100. And that's going to be 0.593. Next, when we are doing proportion, since we're looking at the population, we want to use that normal distribution. And what we want here is we want a critical value z sub alpha divided by 2, because that's going to be part of the process of getting our margin of error. The margin of error is found by taking your critical value, z sub alpha divided by 2, times your p-hat times 1 minus p-hat divided by the sample size. And once we get that margin of error, then we are able to construct a confidence interval around this p-hat value. So we need now that critical value. With proportion, like I said, with the normal distribution, most classes, most textbooks, most classes will just use this table right here. Let me move myself out of the way. We'll just use this table. That's typically the table that will, sometimes you might be in a class where they might want you to find, but these are pretty much set in stone for the normal distribution. And based on our different level, I'm going to go down to the corner here. Based on our different levels, 90%, we just use this table. So 90% level of confidence, the critical value that's going to be associated with 90% is 1.645. Then if it was 95, we'd use 1.96. 98, 2.33, 99, 2.575. So we are constructing a 90% level of confidence. So we're going to use that critical value, 1.645. Right there. Okay, so we have that. So now we could start calculating our margin of error. Margin of error is found by taking your critical value, 1.645, times your p-hat. P-hat we found to be 0.593, times 1 minus 0.593, divided by the sample size. We have a sample size of 1,100. And then it's just going to your calculator. When I teach this to my classes, I really take my time with using your calculator. What I like to say is I like to do the inside of this square root. I get all those numbers, and then I do this square root of that answer, and then multiply that by 1.645. So I'll go ahead and do that. So I do 0.593 times 1 minus 0.593 divided by 1,100. Then I get that answer. I hit second square root, second answer, get that answer, times 1.645. And I get an answer of 0.024. So that is my margin of error. Some people are really good at just typing this all into one screen. But if you want to be careful, the calculator has a mind of its own sometimes. And you think it's going to interpret what you type in one way, but it's going to take it a different way. So you just got to keep order of operations in mind when you're typing things in your calculator. So we have our margin of error. So from here, we are going to take p-hat. We're going to add on and subtract off that margin of error, because we're creating an interval based on a level of confidence. So p-hat, we calculated to be 0.593. So we're going to add on the margin of error of 0.024. We take our p hat, 0.593. We're going to subtract off our margin of error of 0.024. So our interval here is going to be 0.593 plus 0.024, which is going to be 0.617, and then 0.593 minus 0.024. It's going to be 0.569. So we could also write that as 56.9% level of lower bound, and then the upper bound being 61.7%. So there is our interval, 56.9% to 61.7% based off of a 90% level of confidence. I'm always in the way here. 90% confidence. And just one more time here, this critical value is found from this table. You could use the normal distribution. It's a little bit more work, but why would you use more work when you could just use this table? Pretty much every single textbook that talks about confidence intervals is going to just provide this table for you, and you can just use the normal distribution though if you don't have that available. So hope this helps with estimating a population proportion. If you like this content, please hit that subscribe button, and hopefully see you on the next video.